In this movie, we will see how to develop a confidence interval around the sample mean in the case that we do not know the population standard deviation. If sigma, or the population standard deviation, is unknown, we can approximate it with S, or the sample standard deviation. Because we have made a guess here, we will modify our margin of error. Instead of using the standard normal distribution, the z distribution, we will make use of the t distribution. The t distribution depends on a concept called the degrees of freedom, which essentially in this case are our sample size n minus 1. So if our sample size is, let's say, 35, our degrees of freedom are 35 minus 1, or 34. The t distribution, like the standard normal distribution, is symmetric. And for very large sample sizes, it actually converges to the standard normal distribution. So this is the only modification we make. Instead of using the standard normal distribution, we will use the t distribution in constructing the margin of error around the sample mean. Alpha is our level of significance. So if our confidence interval is 90%, our level of significance, or alpha, is 10. That means that we will have a 5% on the tails. So we divide that by 2 to look at the corresponding t-stat with the area in the tails equivalent to our level of significance divided by 2 and the corresponding degrees of freedom. Let's apply this to an example. Suppose on an average, a family of 4 spends $215.60 on a vacation. We want to see how this population average compares to the amount of money spent on a vacation by a family of 4 while visiting Niagara Falls. So suppose a survey is done of 64 families, and the sample mean on money spent per day from that survey is $252.45. And suppose the sample standard deviation is $74.50. We want to develop a 95% confidence interval estimate of the mean amount spent per day by a family of 4 visiting Niagara Falls. So here, our confidence interval is 95%, so our significance level, or alpha, is 5%, and our tail areas will be 0.025. Our sample mean is $252.45, and our sample standard deviation is $74.50. So to build a 95% confidence interval estimate, we will take our sample mean and add and subtract the margin of error. Our sample mean is 252.45 plus or minus. We will be using the t distribution with the degrees of freedom n minus 1. So the tail area, alpha by 2, and the t distribution, degrees of freedom given by n minus 1, times the standard error of the mean, which will be our sample standard deviation divided by our square root of sample size. So $252.45 plus or minus t alpha by 2, 63, and then our sample standard deviation is 74.5 divided by our sample size, which is square root of 64. So let's see how we can calculate or obtain our t with the tail areas of alpha by 2 and the degrees of freedom 63. To look up a corresponding t-stat with the tail probability of 0.025 and the degrees of freedom being 63, we can use JUMP. So in JUMP, instead of the normal distribution, we'll select the t distribution. We'll input our degrees of freedom, which in this case is 63, 64 minus 1. And we will say input probabilities and calculate the values. Now we want our alpha to be 0.05. Our combined tail area is 0.05. But the t distribution is symmetric. So we can either use the left tail or the right tail. So let's say our left tail area, then we will change that to 0.025, and we get the corresponding value of 1.998. So we will use the absolute value of this because we're adding and subtracting t times a standard error. So using this value, 1.998, I can write my confidence interval as 252.45 plus minus 1.998 times the standard error of our sample mean. And this will give us 252.45 plus or minus 18.61. So our margin of error is $18.61. Thus, we can obtain our confidence interval at 95% confidence level will be $233.84 to $271.06. So this is our 95% confident point estimate of the money spent per day by a family of 4 visiting Niagara Falls. Part B says, how does it compare to the overall vacation population mean? And we see that $215.60 is outside of this confidence interval. In fact, it's lower. So we can say that on an average, we can be 95% certain that the family of 4 vacationing Niagara Falls spends a lot more money than what the national average is. So this is how we can use our confidence interval to draw conclusions about the population mean when we are given the sample and we do not know the sample standard deviation. Up till now, we have seen how to build a confidence interval around the sample mean given our sample size and given our sample statistic, whether we know the sample standard deviation S or if we know the population standard deviation. What about how to choose the right sample size to get a certain margin of error? So now we're asking the opposite question. We have an acceptable margin of error, and suppose we also know the population standard deviation from past surveys. What should our minimum sample size be, which will then provide us a confidence interval within that tolerable margin of error? So in this case, we will fix our E to a certain value, and we will basically work this equation backwards to get the value of n. And if we do some cross multiplying and we square our terms, we get that our n, or the minimum sample size, is equal to our z stat corresponding to our tails, or alpha by 2 squared, and then our population standard deviation squared, assume that past surveys have given us that value, and then our desired margin of error. Let's see how we can implement this in a problem. Suppose we want to do a survey to gauge the meat consumption of Americans. And we want to get a confidence interval which is plus or minus 3 pounds of our population mean. So a margin of error is plus or minus 3. And suppose past survey has told us that the sample size, or the population standard deviation, sigma, is 25. And we want to construct a 95% confidence interval. So what should the appropriate sample size be, which will give us the desired margin of error, or margin of error equal to plus or minus 3 of the population mean at a 95% confidence level? So here our alpha is 5%, or our alpha over 2 is 0.25%. If our alpha over 2 is 0.25, our corresponding z value is 1.96. So we can now apply the formula. Our n is our z alpha by 2 squared times our standard deviation squared, or variance of the population, divided by the square of our margin of error. Putting all this together, our sample size should be 1.96 squared times 25 squared divided by 3 squared. And this equals 266.18. So our sample size should be at least 267 for us to get a confidence interval that is plus or minus 3 of the population mean at a 95% confidence. So again, a very practical implication of how to determine the sample size to conduct a survey to get a certain margin of error.